Good afternoon, everybody. How are you all? Today we are going to talk about a hypothesis test for the mean or small sample when population standard deviation is not known. And we are going to use the p-value method, p as in probability value method. So here is my problem. It is estimated that the average age of a tennis fan is 32. To test this claim, a researcher selected a simple random sample of 18 tennis fans and found sample mean is equal to 31.3 years and S is equal to 2.8 years. Assume the sample came from a normal population. At a level of significance of 0.05 is the average age of tennis player less than 32. There's double S. We will cancel that. So I will go back here. Okay, so let's do this problem. Okay, so let's write the null hypothesis. The status quo is H0, mu is equal to 32. And the alternate hypothesis is mu mu is less than 32. Because that's what we have been asked to test. Okay, now so as you can see, the two slanted lines indicating less than meet at an edge pointing to the left. That means it's a left tail test. Rejection of H0 region lies in the left tail. Alpha is given as 0.05. This is the maximum probability of rejecting H0 when it is true. When it is true. Okay, so alpha is equal to 0.05 is equal to area of rejection of H0 in the of rejection of H0. So, okay. Rejection of H0 in the left tail. Okay, so we know n is equal to 18, less than 30. Sample came from a normal population. That is important to know. Normal population. And S is 2.8. Population standard deviation is not known. Standard deviation is not known. Deviation is not known. So we will use t-distribution to test this hypothesis. Test the hypothesis. Okay. So let me create some space. Okay. So let me draw a picture of the t-distribution. At the center where the peak is the highest is t equal to 0, and the area of rejection, which is the shaded region, this is your area of rejection. This is where we reject H0. Reject H0. Let me write it clearly. So reject H0. And area of rejection is equal to alpha, is equal to 0.05. Okay. So we have to calculate a test statistic. Okay. That is where we will compare the sample mean with the hypothesized population mean. The difference between the sample mean and the hypothesized population mean of 32, the difference will be divided by the standard deviation of the sampling distribution of X bar. So if I create some space, so let's calculate S over square root of N. Remember, S is equal to 2.8 divided by second button. I'm using my TI-84 calculator. Second button, X square button, will give you the square root inside the square root 18, type 18 and enter. So S over square root of N is equal to 2.8 divided by square root of N is 0.65996. This is the standard deviation of the sampling distribution of X bar, distribution of X bar. So T, that is the test statistic, is equal to X bar minus mu 0 divided by S over square root of N. Or the test statistic is equal to X bar is 31.3 minus 32 whole thing divided by 0.65996. And that works out as minus 1.06. So, if I may draw a t distribution again, at the center t is equal to 0, and I have calculated a test statistic value of t is equal to minus 1.06 because this is a left tail test. The probability of getting a test statistic as extreme as minus 1.03 is the area under the t distribution to the left of distribution to the left of minus 1.03. So this is your p-value. And this is your t is equal to minus 1.06. So Don't go away. I'll give you a hint at the end of the show, towards the end. So please stick around just for a few more minutes. Okay. So I'm going to calculate the p-value. For that, use to find p-value, use TI-84. Second button, and then verse button, then scroll down to number 6, which is TCDF. Okay, and press enter. Okay. So the lower is already set up in the calculator. The lower is -1 E99. Where is that in my diagram? This is the left end of this tail, left tail is -1 E99, a very large negative number. Okay, so -1 E99 is fine. My upper is where I'm stopping, is minus. This minus is next to the enter on the calculator screen. Upper is -1.06. So -1.06. Then it asks for degrees of freedom, which is our sample size -1. 18 minus 1 is 17. And then we go to PEST. Whenever you run PEST, if you have watched my earlier videos, you have to hit enter twice. So put the cursor on PEST and hit enter twice. And your p-value, the p-value is 0.1519. That means the probability of obtaining a test statistic as extreme as -1.06 is 0.1519. Now, this means this probability is quite high. Probability of getting this extreme t-value, okay, of -1.06 is quite high. Quite high when 80 is true. Now also compare p equal to 0.1519 with alpha equal to 0.05. Okay. So if I move up, p is less than alpha. Sorry, p is great. What am I writing? P is greater than alpha. P is 0.0519 and alpha is 0.05. There's the order of magnitude difference between the two. So P is is greater than alpha. Okay. So therefore, decision is do not reject 80. As I said, the probability of getting a test statistic as extreme as -1.06 is quite high compared to alpha of 0.05, provided 80 is true, when 80 is true. Therefore, since the p-value is very high, p is greater than alpha, decision is do not reject H0. Okay. Conclusion is at alpha is equal to 0.05. There is not enough evidence to support HA. Evidence to support HA. I also want to draw your attention to a situation when P is less than alpha. Here we got P greater than alpha. So my hint is, if P is less than alpha, the smaller the value of the probability value of getting a test statistic as extreme as what you have calculated, the smaller that P value, the stronger is the evidence against H0. That is my hint. So if the p-value is greater than alpha, definitely you are not going to reject the H0. You do not have strong evidence against H0. So do not reject H0 and do not support the alternate hypothesis. So I will stop here today. I'm coming back next time and I'm solving this problem in another way, another quicker way. So please stick around and check out my new next video coming up. And if you like this video, please give me a thumbs up. If you like this video, please share this video with your friends. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll be back next time with another way to solve this simple problem, much easier way to solve this. Take care. Have a nice day. See you.